This is the story of ANA Flight 140. On the 6th of September 2011, at about 9:15 p.m. at night, Flight 140 was on its way from Okinawa to Tokyo's Haneda Airport. This was one of the many domestic flights connecting the multiple islands of the Japanese island chain. As the plane cruised over Japan at 41,000 feet, the flight deck was calm. The captain was the pilot flying while the first officer was busy monitoring things, making sure that everything was just right. The plane had been airborne for a few hours, and now the plane was nearing a waypoint known as Sakak. With nothing much happening on the flight deck as the plane cruised, the captain decided to leave for the washroom at 10:46 p.m., leaving the first officer all alone on the flight deck to manage the plane. Now, for those of you that do not know, this is completely safe and routine. One pilot can manage and monitor everything on the flight deck while the other pilot is away for a bit, especially while in cruise where nothing much really happens anyway. As the captain was out, the controller at Tokyo's Area Control Center called up the first officer and asked him to reroute the plane just a bit. The controller wanted the plane to fly right towards the PQE VOR. This necessitated a small right-hand turn of about 3 degrees. Nothing too serious. As the first officer received this information, he began programming this new route into the plane's CDU, or Control Display Unit. The CDU was located on the left-hand side of the first officer, just off to the sides of the throttles. As the first officer was busy entering the details into the CDU, he got a chime letting him know that the captain was ready to enter back into the cockpit. With the captain waiting outside, the first officer quickly wrapped up what he was doing on the CDU and started to reach for the switch that would unlock the cockpit door. As the first officer was getting ready to do that, the computers on the plane manipulated the ailerons on the wing so that the plane was put into a gentle 3-degree right-hand turn, just like the controller had commanded them to. Suddenly, the plane jolted to the left. The first officer immediately added some right rudder to compensate for whatever was happening to the plane. Outside the cockpit, the captain felt the plane bank to the left. He heard the warnings going off at the cockpit. He immediately sent another message to the cockpit asking the first officer to open the door, but the door remained tightly shut. As the plane banked more, the captain found it too hard to even open the door due to the G-forces that were at play in the cockpit. The flight computer was also confused by what was going on. The plane was deviating away from the flight path that was programmed into the flight management computer, and the onboard computers were also trying to get the plane back onto the pre-planned flight path. But that wasn't happening for some reason. The autopilot was maxed out at its control authority. As the roll to the left increased, the nose started to drop. Now, there was more air flowing over the right wing and not enough air flowing over the left wing, causing the passenger jet to get into a steeper and steeper roll to the left. This 737 was doing something that a 737 shouldn't really do. Within seconds, the autopilot was at its limit and it was trying to right the plane as much as it could. But whatever was causing the plane to roll to the left was overpowering the autopilot. In the cockpit, the bank angle alert was going off. As all of this happened, the autopilot was not the only thing trying to save the plane. The first officer was as well. He was basically commanding as much right rudder as possible to keep the plane from rolling uncontrollably to the left. The lives of all 117 people on board now rested on the first officer's ability to right the rudder. For a bit there, it seemed like the plane was starting to recover. That is to say that the left-hand bank reduced to 50 degrees. But that didn't stay long as the roll to the left started back up again. As all of this was unfolding, Flight 140 was starting to fall out of the sky. The rate of descent went from about 220 feet per second to about 440 feet per second. At those speeds, the 737 would hit the water in mere minutes, if not seconds. Well, that is if the aerodynamic forces didn't tear the plane apart first. But against all odds, the plane started to level its wings out of its harrowing dive. In the cockpit, a litany of overspeed warnings were going off. Everything from the bank angle warning to the overspeed warning as the plane pushed well north of Mach 0.8. The plane eventually sorted itself out and was flown to the destination airport without any further incident. But now we need to know, how does a passenger jet just fall out of the sky for no apparent reason, and then fly like nothing had happened in the first place? The investigators looked at the weight distribution of the plane. If the weight distribution of the plane was off, it could be a reason as to why the plane did what it did. But here's the problem though. If the plane had weight problems, that would have been apparent from the moment that the plane took off. It wouldn't have shown up out of the blue hours into the flight. For example, look at National Air Flight 102. In that case, the plane never really gained altitude because of how the plane was loaded. Flight 140 was the mirror image of that. What's also interesting is that the problem seemingly fixed itself. That would not be the case with the weight imbalance. This meant that after talking to the pilots, they had to consider a scenario that was so absurd that I'm sure that none of you would be able to guess it down in the comments below. I'm serious, go down into the comments and type out what the weirdest reason can be for something like this. Yeah, I'll wait. Well, are you done? Apparently, the pilot might have gotten the door lock switch and the trim switches confused. So instead of unlocking the door, the first officer accidentally might have trimmed the rudder to the left hard, causing the plane to bank to the left. But that brings up the question, why are the two switches so close to each other? Well, it comes down to commonality, cockpit commonality. Other Boeing planes have had this design, so Boeing kept it the same on the 737-700, meaning that the pilots learning to fly the new 737 would have one less thing to worry about. On the 737, the rudder trim switch is spring-loaded, which means that when you let go of the switch, it snaps back to its center. The rudder moves as long as the switch is deflected. The thing is, the rudder trim basically makes no sound when the plane is in flight, so it would not have been immediately apparent to the pilot that he was deflecting the rudder and not opening the cockpit door. Moreover, the feel of both switches are very similar. That is to say, the cockpit unlock door is also spring-loaded, and it also snaps back to its neutral state when you let go of it. This means that from a tactile point of view, both switches are very, very similar, and if you aren't paying attention, you might grab the wrong switch and accidentally send your plane into a dive. What's even more interesting is the fact that the first officer used to fly the 737-500, and I know that all Boeing planes kept the switches on the same panel for cockpit familiarity, but they did move it around a bit, and in this picture you can see how the switches differed on both planes. As you can see, the trim switch on the Dash 500 is kind of near where the door selector is on the Dash 700. The really scary thing is how close they were to disaster. Sure, they weren't close to disaster in terms of altitude, but planes have crashed for less. In certain situations, when pilots are given things that they cannot handle, they get startled and then they can't react fast enough and end up crashing the plane. That sounds silly, but it has happened. Take Air France Flight 447. The pilots in that case accidentally put the plane into a stall and crashed it because they were thrown an error that they were not expecting. Or AirAsia 8501, the same thing applies. What's really interesting about this crash for me is that the pilots are trained to operate something as simple as the door lock selector. Like in the Air Operator's Manual, they have a section dedicated to how to do this simple task. This just goes to show you how much thought and effort has gone into making these planes. So, how do you prevent something like this from ever happening again? Well, one thing that we can do is for training to teach pilots the difference between the lock selector and the trim switch. Well, duh. But the more important one, in my opinion, would be upset recovery, simply because it can be valuable in so many more scenarios than just this one. Let's go back to the crashes that we discussed before. In both cases, the plane was perfectly flyable. Had the pilots had better recovery skills, they could have saved their plane. Also, pilots can and should be given more training on how to manage the flight deck with just one pilot on the flight deck. Because when the other pilot is gone, there is no one to catch your mistakes and correct them. So it's a totally different operating paradigm. The interesting thing about all of this is that the recommendations for this accident isn't hyper-specific. It's all just stuff that can make pilots better pilots. And that's all. What do you think about this crash? Did you expect something like this to happen? If you've got a thought, let me know down in the comments below. Thank you for watching this episode of Mini Air Crash Investigation. If you like the videos that I make, do consider liking and subscribing. It will really help the channel grow. I will catch you guys next time. Stay safe.